Uh, my name is Carlos. I originally come from Chile, all the way down south, South America, and I've been living for the past 12 years in Norway. Now I work for Schibsted, and I'm going to talk to you about routing and events. So, what is this presentation about? I'm going to tell you about Schibsted. I'm going to tell you a short story about data, how data is used in Schibsted, and what kind of things we do. A short sidetrack on GDPR, and finally I'm going to introduce you to our tracking solution, which is called Pulse. So first of all, how many of you have heard about Schibsted? Only one person, and you are in the business there with big data and all that. Okay, Schibsted is a Norwegian company, and I have planned to bore you for about 5 minutes telling you who Schibsted is, but our company last week launched this video, so I'm going to show you this video about who Schibsted is. It's much more interesting than listening to me.
On a cloudy day in Oslo, 1839, Christian Schibsted decided to stop waiting for others to make things happen. What started as a small printing shop soon turned into a newspaper, Aftenposten, which he set up not only as a business venture, but also to make a statement for democracy and free speech. A rather bold move back then. This move also laid the foundation of Schibsted's ambition of empowering people in their daily lives. And we've been pioneers in this field ever since. Our newspapers have grown into publishing powerhouses and leaders in digital subscriptions. We revolutionized the classified ads arena, and we democratized consumer loans and price comparisons, and much more. The list goes on. Today, all of our products, news, marketplaces, and smart digital services have more than 780 million users per month across a wide variety of brands. But we're far from done. Rethinking things is at the core of our DNA, and this is why we are well underway of diving deep into new territories such as artificial intelligence, machine learning, and big data. We're going to dig even deeper into user behavior in order to meet consumer needs even better than today. We'll use this to rethink and develop more groundbreaking services and products that will push both ourselves, our customers, and the market forward. And we're more than able. What was once a small printing shop, set up by a man determined to change things for the better, has grown into an international, innovative tech company. Always with our feet on the ground, and always with a humanistic approach to further empower people and contribute to society. This is what we do, and this is what we'll continue to do. We have the infrastructure, the ideas, and the ambition to continuously hit the next big thing, because that is what happens when you've been rethinking things since 1839.
So, in short, Schibsted is a leader in the Nordic market. We have newspapers, we have media, other media concerns, we also have marketplaces, and we are a company that invests in a lot of new companies. So we all the time are acquiring or investing in new companies that bring small services, for example, community loans where you can get together and loan money to people and all that kind of stuff. So let me tell you a story and show one of our marketplaces. Let's say that I'm a consumer and I want to buy a new washing machine. I go, of course, one of our marketplaces. This is called Theme. It's the largest marketplace in Norway. And either using my computer or my mobile, I find an appropriate washing machine that fits the criteria that I want. Then Behind the scenes, Finn is sending data about this query. What is happening with this data? Well, this data goes to our collecting machine. It's being put into a log where eventually it will be processed and routed and written to a Kafka backend. At some point in time there will be a dispatch and this data will be sent back to Finn. And Finn will receive this payload. What will Finn do with this? Well, they will use this payload of information to look into their own records and show me relevant ads for my query. Maybe the washing machine that I'm looking, there are some others that might be better suited to what I'm doing. So this is what we achieve with our data. This is what we want to do. And of course, we have plenty of different use cases. This is just one of them. Before we dig into how we do things, I would like to talk to you about something that you have heard a lot today, which is GDPR. GDPR was a game-changing. It's a new European law. It targets companies that target people in the European economic area. It doesn't mean that you have to be European or that you have to be a European company inside the European economic area. As long as you are targeting somebody that is physically in the European economic area, you are bounded by GDPR. And GDPR is a very comprehensive law. I'm not going to go into all the details. I'm just going to tell you the two main things. It grants rights to users, two very basic rights. Data portability, which means a user can come to us as Schibsted and say, I would like to have all the data that you have on me. I want it in a readable format and I want to be able to take it with me. Or just check what you know about me. The second right is the right to be forgotten. The same user can come to us and tell us, I want you to delete everything you have about me. You are not allowed to have any more data about me. Which puts quite a lot of constraints into what you can do with this data. And in addition, for providers or other companies, it sets 6 different legal bases for collecting data. You're not allowed to collect data unless you're based on one of these reasons. The first one is the easy one. You can ask users, I would like to use your data to do this, this, and that. It cannot be asked in a very technical language. It's very clearly defined what kind of vocabulary you can use. So when you ask the user, I would like to use your data for this, it has to be understandable by users. The second one is the processing obligation. What does this mean? If you as a user are asking us to do something for you, well, I will have to have some data about you. If you're buying something from one of our companies, well, we need to know your address to ship what you're buying. Without your address, we cannot fulfill our contract. The third one is a legal obligation. And the legal obligation is basically the law says that you have to collect that data. If somebody is transferring money, if somebody is doing something that the law says that you have to do it, well, you have to do it. There is no other way. The fourth one is the vital interest. And this is in your own interest. For example, if you suffer an accident and the ambulance comes and asks you what is your blood type, or that kind of stuff, you don't want them to give you a form that you need to sign and all that. The ambulance people are allowed to do this because it's in your own interest that they know about this kind of thing. If they ask you, do you have any disease or anything that we need to know in order to save your life? The fifth one is public interest. Public interest means it's in the interest of the society. The society as a whole has decided that some information is available. And the final is the legitimate interest. The legitimate interest means I, as a provider, I do not need to know this information, but if I know this information, I'm allowed to give you even better services. I can, for example, recommend you different washing machines than the one that you're looking at. So that's a very short and concise version of GDPR. And now with GDPR out of the way, we can introduce Pulse, our tracking solution. Why do we have polls? In time, we evaluated different tracking solutions, and we realized that data is so important to us that we need to be in control of data all the time. We have to be able to control the whole thing, so we created our own ecosystem that is parallel to Google tracking and everything else. What is the pools ecosystem? Well, the pools ecosystem consists majorly on 4 components. We have the tracking SDKs, we have a data quality, we have, of course, data and statistics about the data, and we have an administration portal. So, let me show you a little bit more detail here. We have the following SDKs on the right and the left side. We have Android SDK, we have an iOS SDK, and we have a JavaScript SDK that you can use from web clients, backends, and other devices where you're not on one of the mobile platforms. Then we have the machinery that does the collection and routing. And finally, we have 2 ways of delivering data to you when you're a consumer of data. We can either deliver data as a batch processing, so you can run it at your own pace, or we can stream data to you so you can do real-time analysis of data. Now, the reason why we have structured this is because we have many different use cases. As I said, Schibsted is a company that involves many other companies and small companies, and they all have slightly different use cases. They all have different requirements. Sometimes there are cross-company functions that require that, okay, we collect data for all of them and run some analysis. So it's very difficult to actually find one solution that matches all of the use cases. Therefore, we decided, okay, for those who need batch data, we are going to give them batch data. For those who need real-time data, we will stream data to them. Now, so what is it to be an event in our system? Oh, sorry. Before we go into that, we have how much, in my presentation says how do we do routing for 1 billion events a day. So how much is 1 billion of events a day? Well, if you consider that the day has 86,400 seconds a day, it's way more than that. It's way more than the milliseconds in a day. That means that when we are processing very little traffic, we are receiving approximately 5,000 events a second. An event might be anything from a few bytes of data to several kilobytes, and in some cases even megabytes. When we are in high traffic hours, we might be processing about 25,000 events per second. We usually don't count per second because per second is very unreliable, so we count in a larger interval, such as 30 minutes. In 30 minutes, we're processing about 5 million events. But we also have peaks. And peaks are anything when we are processing more than 100,000 events per second. And when it's a peak, well, let's say, God, I hope that it doesn't happen, but if a bomb blows somewhere, there will be a peak in our news sites. That means a lot of people will be accessing those. And suddenly you don't know. You have 100,000 visitors in a couple of minutes. This is very ironic, but our system has been able to scale to a lot of the news things that have happened, including the election of Donald Trump as president and plenty of other things. But the one thing that our system wasn't capable of scale to was 2 years ago when a reality show ended in Norway, and the country was so divided between the people that won that everybody was commenting and doing stuff. And that thing was it was about 500,000 events per second, and that thing actually managed to crash our system. It's the only time that we have had a hard crash, and it was because of a reality show. Sad things these days. Well, what is it to be So, what is it to be an event in our system? You as an event are produced by the SDK. Now, the SDK, and I'm going to talk a little bit in more detail a bit later, will produce a kind of event, and that event will be transparently sent to our collection service. Our collection service is nothing more than a front end, a REST front end, where we collect data, and we put it automatically into two Kinesis streams. Those Kinesis streams are located in two different regions in Amazon, so in case we manage to crash one of them, the other one is still available. Our system is capable of handling a whole Amazon region going down. And once you are an event, you are in Kinesis, then in the batch pipeline, we have this service that is writing all the time to S3. It processes in an hour, that's the interval that we do. So we start 1 hour and start writing events to a given bucket and mark them as that day, that hour. And eventually there will be a batch job that will run there. If you're in the streaming pipeline, then from the same Kinesis, we write to Kafka. And from Kafka, we have this tree here. This tree is called Yggdrasil. It's a Norwegian tree. It comes from all the way from the Vikings. It's the tree of life. And it's the metaphor that we use to signal the processor that creates everything. So this tree will take events and put them again in Kafka, transform. We'll see the details very soon. So, what is the internals of this? We get JSON, that's our event. And we have recipes. Those recipes will go into this processor and we will create new data. That will be put for dispatching. And now, all this happens automatically. We have the same processing for both the batch and the streaming pipeline, even though it sounds very contradictory that we are using the same routing processing. We have this routing lib where all the logic for routing, transformations, filtering is implemented. And this routing lib takes JSON, our routing language, and produces the data that we need. In addition, it has this loop, which is constantly monitoring the routing configuration. If there is a new version, it will reload it and continue processing events based on that. I'm talking a lot. Talking a lot about the routing language, and the routing language looks like this. I'm not going to discuss why we chose YAML as a routing language instead of JSON or others. Our routing language is describing YAML. On the right side, you see the generic declaration of what we call async. Async is basically whatever you tell us to produce the data to. So we don't care what kind of backend you're using, we don't care about that. We care that you ask us to produce data on a given format. And how do you specify? Well, the first thing that you have to specify is the event type, which leads to the event schema. We're going to talk about the event schema. Then we have the filtering. Basically, how do we decide whether this event is of interest or not? We have transformations. This transformation tells us, okay, here's the event, but this is what you would like to get out of the event. And finally, we have the sync types. And the sync type, we have several sync types. We can write data to S3, we can write data to DynamoDB, we can write data to SQS, to Amplitude, to Snowflake, to a lot of other different backends. As I said, this all comes from the fact that we have several companies and they all have their own tools and they all want data in their different way. On the left side, you see a typical event. This one is a very simple event. This is what we use internally to monitor the latency of our system. It's called the probe event. It has a schema that is well defined, and it's a sync of type Kafka, which means it will be written to our Kafka cluster again, and in that given topic. So, Event formats. This is, we have realized that many people talk about data formats and all that, but we decided that the best way to keep track of things is by having schemas and defining event formats for different actions that might be at least similar across companies. For example, we have the probe event, as I said. There might be the event that it's logging, that it's also similar, at least in different companies. We also have our own authentication provider, so we know that it's very similar. We have tracking events, we have view events, and all sorts of events, and you can specialize those events if you want to. But the important thing is that we have a repository with all the schemas that we have, so we can track which version of the schema we are talking about. That gives us a lot of flexibility, because a lot of people think, okay, I'm tracking this event, I'm just going to change the payload of this event from my web application or from my mobile application. Instead of having this as a string, I'm just going to send an object, and suddenly all the pipeline and the BI and everything breaks down the line because they were expecting a string and now it's an object. So with this kind of a schema, we can just say, oh, this event doesn't fulfill the schema. We will make it safe, which means we will have a collection process in which the event will be put into a different format. JSLT. JSLT is our magic language. We use it for query and transformation. JSLT is a language that we wrote, created, and have open source. Anybody can use this language. It's a JSON transformation and query language. It's a very simple language, yet very powerful. You can use it to convert things. You can use it to just adapt things. For example, if you look at the first field there, the field called time, we are telling it to, based on the publish field in the event, with that format, parse the time, multiply it by 1,000 to get the milliseconds, and then round it. And it will give us a very clear and simple way to modify stuff. You can say that other fields are just, okay, device manufacturer, I'm just going to change it from the .device .manufacturer, and that kind of stuff. It's a very powerful language, and we allow our consumers to actually specify the transformations from that. Now, with all this, let's go back to the routing that we were doing. How do we do the routing considering the routing lib, JSLT, and all that? As I said, we have data in S3. We have been writing data to S3. At some point, we have, once an hour, we have this batch job that is written in Spark that will read that data from S3 and write it to different S3 buckets. Our latency is usually about 2 hours. So you will have the data 2 hours after it was produced. Unfortunately, we are not there yet. We usually oscillate between 2 to 4 hours. And now, on the streaming side, how does it look? Well, as I told you about Yggdrasil, Yggdrasil is the one that reads this language and produces the transformations, filters the data. Yggdrasil is a Kafka Streams application that is running this routing library and writing to Kafka. From there, we have this other mythological animal called Duclos, which is a deer that lives near the roots of the tree of life, also from the Vikings. And this Duclos dispatch the data to whoever needs it in whatever format it's needed. This way we are decoupling everything. We don't have if any piece of the pipeline falls, we have decoupled everything. So we can scale each side of the pipeline without thinking about, okay, how do we affect everything? We can just turn the knobs all the way. So what have we learned doing this? Well, and it's interesting that of all the presentations that I've heard, I don't speak Russian, so I didn't understand what happened in the last presentation, but I saw the slides. But it's very interesting that he mentioned, or at least the slides mentioned, several of these points. Schemas and versions. It's very important that you control the data that you are having. At least in a large way. You don't have to be very fine detail, but you have to agree on, okay, this is the minimal data that will be there, and this is the format in which I will have it. And you have a process, a procedure to actually version that data. The schema. Okay, this is schema's version 1, this is schema version 4. This event was produced with a... The typical problem that we have, for example, is somebody that is using a mobile app hasn't updated that app in years, and they are still sending events. That event will come with a schema that it's maybe a couple of years old. What do we do with that event? Do we drop it? No, we know that it belongs to this type of a schema, this version of the schema, so we can go back, say, okay, this is the schema, we treat it like that. Backfilling and recovery. Recovery, it's probably the one that you have thought, I hope at least. Recovery is things are going to go bad. At some point, the system will crash. At some point, it will overload. How do you recover from that? Do you have a procedure? What happens if suddenly you lose data? And that's where backfilling comes from. Okay, I lost a full day of data, but I still need that for my models. How do I go back in time and produce that data again? Do I have a strategy? For how long can I do it? Can I do it for data that was produced 6 months ago? Can I do it for data that was produced a week ago? You need to think about those two. Logging and metrics. You cannot have too many metrics. Please add metrics all over the place. You never know when you need a given metric. And logging, it's very easy to think, oh, logging is going to make my application slower. But it's much better to start with too much logging and start removing those messages that you don't know than start with too little logging and not knowing what's going on. When you have both good logging and good metrics, it's very easy to debug problems. When PagerDuty, the previous presenter was mentioning, calls in the middle of the night at 3 o'clock in the morning, and you need to have a wake up and try to find out what happened. You have good metrics, you have good logging, you can probably diagnose and find a quick solution to the problem. And finally, auditing. If you go back to GDPR, it's very important that you know who accesses what data under which circumstances. It's very important that you can prove that, yes, I have control over the data. I know who accessed that data. I know what they did with that data, and I know where that data is stored right now. It's very important that you have this auditing. And finally, well, we are hiring. If anybody is interested, please come and talk to me. We have plenty of open positions. Okay, thank you.
Thank you very much. Есть вопросы? Вопросы? Сразу два.
Hello, thank you for the presentation. So, first question will be about metrics. How do you manage them and how do you review them?
Yeah.
What tools do you use and what's the approach?
Yeah, so here there are, how do we produce them? Right now we have abstracted the metrics from the backend where we are storing them. So basically we can change the backend, but at this time we are using Datadog and we are evaluating Prometheus. We are also investigating creating our own solution, but we are right now doing that. With Datadog, we have dashboards, which are the ones that we have a big screen and you can look at them. And from there, we also create alarms and triggers that tell us, okay, we have a Slack in Schibsted, So we have a bot that is constantly posting there, okay, this metric is going above the threshold that you're expecting, now it has changed to yellow, the situation is yellow, you might need to look at something. How do we manage in the term of what do we measure? Well, we are very liberal. If you want to have metrics, have metrics. We don't actually have a strict process to decide which ones comes in and which one goes out. If you want to have metrics, just add them and we will take care of them.
And another one, thank you, would be about the tech stack for the services you mentioned, the mythical animals and plants and trees and everything. Thank you.
Yeah, so if we go back here, Yggdrasil is written in Scala, and Vergara is also written in Scala on the streaming pipeline. We, on the batch pipeline, we are using Spark, also from Scala, and we have the collector service, which is also written in Scala. So yeah, pretty much we can say we only use Scala. But we also have, for the batch jobs, we use Luigi with Python. So in order to coordinate and all that, we go on that one instead of Airflow. But I'm not going to go into that battle.
У нас еще было до вас.
Well, thanks. My question will be related to GDPR. And actually, this is a really interesting topic. I didn't quite get how do you place this GDPR layer on top of your system. I imagine that it's somewhere between this, where consumer actually can get the structured data potentially. I mean, when your data is processed and then consumer can get it somehow. So probably the GDPR is applied somewhere there, or if you please, can you please talk about it?
Yes, so there is something that is not in these pictures here. Here. We are collecting data on this side, but in the previous slide, we have this administration portal. This portal here lets different roles do different things, and one of them, well, you don't see very well there, but one of them is for companies or people that want to start tracking. So if you want to start tracking, you register yourself. Tracking means that you are going to start collecting data. When you register with our system, we will register you as a data store, which means you are storing data. And we have another system that is called the privacy broker, which actually keeps track of all these data stores. And whenever a user comes to one of our systems and tells, I would like to get my data, the privacy broker will receive a message and it will coordinate with all the data stores that are relevant for that particular user and ask them, okay, give me all the data, and it will coordinate all the communication and all that. So we have a centralized system, but it's very federated, if you want. Every company is responsible. Every company that is tracking is responsible for handling the data the way they, according to the GDPR. But we control the process in the terms that we are constantly telling them, okay, you need to give me this data, you need to delete data for this user in whatever format you have.
So basically, as I understand, you are not hiding the data. I mean, something is sensitive PII data. You simply build this solution that allows to delete all membership data.
Okay, that part, yes, that part is different. We have retention policies. In Schibsted, you're not allowed to use personal identifiable data over 30 days. We usually do not recommend anybody to use personal identifiable data. But if you have to, you're not allowed to use it over 30 days. Why 30 days? It's not just arbitrary. It's just GDPR says that you have 30 days to comply. If you do not comply within 30 days, you may be fined up to 4% of your worldwide income. In the case of Schibsted, that's a lot of zeros. That's why everybody that it's using has to abide by that. But we try to de-identify and anonymize the data as soon as possible. But some use cases require personal identifiable data. For example, some of our community loan companies, unfortunately they need to know. And that's why. Thank you.
First of all, thank you for your interesting presentation. As an engineer from one of the big companies that have history and experience on the cutting edge, it would be very interesting for me to know what is, in your opinion, one of the most big insights for you as an architecture or programmer in recent years in the transition of the system. What did you find that works better than you thought, or something that you changed and gave a huge impact on your system? What do you think? I think it's never possible to plan everything and do it and it works. Thanks.
Yeah. So evolution is more powerful than what you think. Even when you start with the best possible plan, you will change it as soon as you start implementing the stuff. So in our case, we have settled into decoupling systems as much as we can. And that's why we have very clear verticals. We have the collection pipeline that is separated from the processing and routing pipeline, which is separating from the dispatching. And the privacy comes as a horizontal underneath, giving us all the pieces together. As a company, we have settled into some technologies, but technologies change all the time. At some point in the past, we were using Redshift. Now we're far away from Redshift. At some point in the past, we have evaluated other programming languages. We are now settling in Scala and a little bit of Java for some things, Python for some others. I think that the biggest learn is decouple and have metrics and logs. If that's the only thing that you learn from this, I'm very happy, because those are the two most important things: decouple and loggings and metrics.
Thank you. Вопрос